I mentioned this earlier. Before we do example number 3, I want to clarify something. The word congruent, and Mr. Adams will always write it like this. That's the symbol. Wow. So, let me at least at first kind of give you an idea of what it's supposed to look like. It's an equal sign with the tilde sign on top. So whenever you see that, that's Mr. Adams' lazy mathematician way of saying congruent. Now congruent means same. Now if I say congruent triangles, I mean the triangles have the same angles and the same side lengths. If I say congruent segments, I mean that the segments, well, they're only one dimension, so it can only be the lengths, right? There's no angle with the segment. All right. So if I did something like this, because I cloned it and I know that these are exactly the same, I have A to B and I have C to D. Well, I can say with confidence, because I cloned them, that A, B is congruent to C, D. Okay? Now, I want to clarify something. We've been doing this kind of loosely, and I just want to point something out. What's the difference between this statement and that statement? Because technically, Mr. Adams made a little bit of a mistake. What's the difference between those two? Yes?
With the bottom one, we know that you're talking about congruent line segments because you put the little line over the A, B, and C, D. And with the top one, you don't know what you can drop. Like we talked about variables and such, measurements.
Well, you were correct on the first part.
Oh, yeah. Thank you.
Okay? Those two statements are different. Notice that I have an equal sign for one and a congruency sign for the other. The first statement, AB equals CD, I'm saying whatever this length is, if AB is equal to 7, let's say it's 7 units, right? Like this is 0 and this is 7. Well then CD, because it's congruent, would have the same length. So the first one I use an equal sign because I'm really just comparing the numerical values, right? That's all I'm comparing. But because they're line segments and they're only in one dimension and they are the same length, then I can say that line segment AB is congruent to line segment CD. It may not seem like a big deal right now, but later on when we start to talk about congruent triangles and congruent figures, there's a checklist. In order to say that a triangle is congruent, they have to have the same side lengths, right, which would be like the top statement. But I'd have to make sure they have the same angles, which, by the way, could be done the same way. I could say the angle A is equal to angle C or whatever. But then at the very end, if the side lengths and the angles are equal to one another, then I could say that the triangles are congruent. Does that make sense? So we're going to learn the notation now with just line segments. All right. So now with that being said, let's do an example. So the actual example number 3 goes like this. And I'm not going to draw it to scale. This is -2a. Over here, we have 3, which is b. 5, which is c. Okay, over here we have 10, which is d. And e is 14. And it says R AC and BD congruent. Now when I have the line over it and I have the congruent symbol, what I'm really saying is this true? Well, for a line segment, because there's no angles involved, I really just have to prove that the length of the segments are equal. So to prove this, to prove AC is congruent to BD, I just need to show that AC is equal to BD. So now AC has a distance of the difference, the absolute value of the distance. So it would be -2 minus 5, right? Which is 7. BD has a distance of 3 to 10. Whoops. So that would be 3 minus 10, which is -7, but the absolute value of -7 is 7. And I'm going to do this informally, and we'll eventually ramp up to this, but I'm just going to say, I'm going to pretend to be you guys, because AC is equal to BD, then AB, the line segment, is congruent to, AC is congruent to BD. Okay? Does that make sense? Now, if those two numbers weren't the same value, then I couldn't say that. Any questions on that?
So you find like the -2 minus 5. How do you? Because I don't know the difference. Because I know what absolute value is, but I don't know how to show that in two negative numbers.
Yeah, that's a great question. So the question is, like, Mr. Adams, I see you throwing some numbers in there. I'm still a little fuzzy. All right. So think of it like this: the distance is equal to the absolute value of x sub 2 minus x sub 1, which is also equal to the absolute value of x sub 1 minus x sub 2. So because we're taking this absolute value stuff, it doesn't matter which order we put the numbers in, but we have to remember that the formula always has a negative sign. We're always taking the difference. So, for example, when we calculated we'll do BD so you can see it here. BD is equal to, and I'm going to plug this in. This is the formula. We're going to take the absolute value of the difference of the numbers, right? So now, the way I did it the first time, I just said 3 and 10. Why? Because B was at 3 and D was at 10 on our number line, okay? But that should be equal to 10 minus 3. It gets confusing when you have negative numbers, but if you remember that the formula is the first number minus the second number, or the second number minus the first number, and you remember to put in those negative signs, it'll always work out. Now here's the interesting thing about this. If I do it this way, 3 minus 10 is -7, and 10 minus 3 is 7. Now the reason we put the absolute value brackets in there is so that we're really only worried about the distance, right? We're not. You got to think in terms that the negative and positive sign are referring to the direction in which we travel. we're only worried about the distance. So I'm gonna expand a little bit more because it'll be helpful later on down the road. So at 3, I have B. And at 10, I have D. Now this first one that I do, the distance between the two, there's only 7 steps. Okay? So when I do it this way, and I get a -7, where am I starting at? Well, believe it or not, I'm actually starting at D, and I'm going 1, 2, 3, 4, 5, 6, 7 units in the negative direction. But the absolute value is 7. I'm still only moving 7 steps. But if I do this, what am I really doing? I'm starting here and I'm going 1, 2, 3, 4, 5, 6, 7, but it's in the positive direction, right? Because when I go to the left, I go in the negative direction. When I go to the right, I go in the positive direction. But I don't care which direction I go in. I only care about how many steps I have to take. That's why we put the absolute value brackets. Because the absolute value brackets just gives us the distance. Does that make sense? I don't know if I answered your question. I probably answered it about 30 seconds ago or 4 minutes ago. I just wanted to keep on talking. All right? Okay, cool. Any other questions? All right, cool.